Then if we want to reproduction, in the reproduction we have two operators, crossover or mutation. Reproduction, it means improve. You have solutions in your hand or in your memory, and now you want to do some improvement to these solutions by doing crossover and mutation. By selected the parents that to do to be improved. By generating offspring from two selection parents by using single crossover or 2-point crossover. In the crossover operator is like you should select two parents or two chromosomes. In this also can be a different approach to different strategies can be used by to vary the programming of chromosome from a generation in the next to the next. It is analogous to reproduction's biological crossover upon which genetic algorithms are based. Crossover is a process of taking more than one parent, as I said, is take more than one to generate producing or generating a new solutions. We call them child solutions. As we said, there are two techniques: 1-point crossover, 2-point crossover, or uniform crossover. In the 1-point crossover, you have to select like you have two parents based on the selection technique with the roulette or tournament or random selection. Then it will generate another two solutions, these two new solutions. Okay. So let's say you have a select here, then you 1 point. When you say 1 point, you have to select 1 point, which is here maybe in this example, it select this gene number 1, 2, 0, 1, 2, 3, 4. So in point gene number 4, it can be do 1-point crossover. So from the beginning, the first gene to the number 4, 0, 1, 2, 3, 4. Then you will put as a plane here to divide your chromosome. So here you do crossover. So this will move here and this will be here. Okay. So the new generation, this is new child 1, this is child 2. So this is parent 1 and parent 2. So this one new unit. So this one then it will be stored in the new population. It will be stored in the new population. This is 1 point. Or maybe you can do 2 point. 2 point is to 2 point here is to select the first point. Maybe it will be selected this point and this point. So here I will do crossover with this data here, these genes. So these genes will not be changed, only these genes will be changed. So these genes here will move to this part and this part will move to this here for the parent 2. Parent 1 will move here and then parent 2 will move to parent 1. So another child, so maybe this one, child number 3, child number 4. So this is maybe parent number 1 and parent number 2. And these two childs will be stored in the new population. Or we can do mutation. There is another operator called mutation. Mutation is the operator used to maintain the genetic diversity from a generation of populations. Here only one single chromosome will be selected, not two chromosomes. Two chromosomes only in crossover. In mutation, we select one chromosome. Then we have to select its mutation alters one or more genes values in a chromosome. So if you have a chromosome, let's say this is chromosome. In mutation, maybe you can select this one, this data, or this gene here, and maybe this gene here, or maybe only one. And then the values here will be changed only, and the value also here will be changed. The rest here will be still same. So the next solution will be same as the parent, but only this here will be changed. and this value will be changed. Okay, in some mutation maybe just swap, because if there is no external data, because if you have like sequence of data here, like you have A, B, C, D, E, F, G, you don't have any other solutions, you have only A, B, C, D, E, G, then you can just change the value. So A, B, then B will come here, and then the values will come here. All right. This is show example how the parents will change. Like here, I select probability mutation to be with this probability between 0 and 1, and then maybe select this one randomly or by techniques to select each any gene in that chromosome. So it will be select only one or more than one. Okay, so the values here, because you have only binary, so the values will be changed from 1 to 0. So this is the child. This child will be stored in the new population. After I finish generate all the populations, I mean the new population will be fulfilled with the new solutions. Then I have to check the objective functions or fitness functions for each new child, and then we'll keep repeat that until finish. So let's take an example to explain. In this part here, in this part, we can explain the genetic algorithm with an example. Let's start by this problem. As we said here, what is the first step? You have to initialize the chromosomes, initialize the population size, identify the fitness functions, okay, and find the range of the data for X. So let's, in this here problem, we find the maximum value of this function. So we have f of X say I have X of X equal 15X minus X squared. So this is my objective function or fitness function now here. I declare it. And then I have X here. X is a range between 1 to 15. So how can I use it as a as a genetic algorithm? So I have to represent X as a chromosome. To change or to represent the X as a chromosomes, we can know that 1 to 15, 15 by binary is 4 ones, and so we can represent each chromosome by 4 bits of 4 bits, which is 0, 0, 0, 1. So this is the chromosomes. Okay, so I have chromosome from value number 1 and value number 15. So suppose that the size of the chromosome population, if we select any size, like if we have a 10, then we say we generate 10. So if in this example we select 6 solutions, so n is equal 6, then we initialize with n with 6, and cross probability here. This one is you have to select the values. 0.7 have been selected. These values you can select any value. So to solve this problem, because the probability of crossover is between 0 and 1, there is studies, and have also how to select the best value. This one also another issue, but for now, for your information, you can select what others they select for now. But maybe in the future, if you want to build your system, you have to select the best value between 0 and 1. So that there are different approach to select that value, dynamic selection or randomly, or use another algorithms to solve this problem. So that's one also, it's called optimizations problem, to select the best value. Okay. Also for probability to do mutation, here in this example we initialize it 0.001. What does it mean 0.001? So I will do mutation with 0.00 means 0.1%. Here I will do crossover 70%. Okay, 70% I can do crossover, but here mutation is very low. Okay, how to do mutation and how to do crossover? You select this probability. So as I say, you can